So yesterday we saw that there is a second algebraic way that we can solve systems of equations, this method of elimination. And we saw that to make this work, you have to have the coefficients in front of one variable be the same or the opposite or the other variable. It doesn't matter. Most equations are x and y, but that isn't always the case. They can be any two letters keen, right? So if the coefficient in front of one set of variables is the same, then you subtract the equations to eliminate that variable, solve for the other. If the coefficients in front of one set of variables are opposites, you add the equations together to eliminate that variable, solve for the other. We saw that in some cases you need to multiply one or both equations by a constant before you can do that step of using elimination by adding or subtracting the equations. So we'll do some more work with these equations today, except now we're going to write the equations first and then solve them. I sent an email out this morning that tomorrow will be our last lesson on this chapter. On Thursday, you're going to write a quiz for chapters 8 and 9. Remember, 8 we solved the systems graphically, 9 we solved them algebraically. So you're going to write a quiz on that on Thursday. You'll also get the review to start working on. On Friday, we'll go through that quiz, and you'll have more time to work on the review. And then Monday will be your next exam on chapters 8 and 9. Okay, also part of that email was a reminder that all missing assignments are due by Friday, June 9th. After that, the blanks will be changed to zeros in PowerSchool, and your marks will go down. So you definitely want to get on that sooner than later so it's not such a mad rush at the end trying to get your assignments done. Also, if you're missing any of your assignments that you don't have those sheets anymore from the packages, then you need to ask me, give me a list of what you need, and I can dig them out for you. All right? So, we're going to continue using the method of elimination today to solve these problems. First one says that Connor downloaded 2 orders of games and songs. The first order consisted of 5 games and 4 songs. The second order consisted of 3 games and 2 songs. The first order was $26, the second was $15. All games cost the same amount, all songs cost the same amount. Write a system of linear equations to determine the cost of one song and the cost of one game. They're telling us what we need to figure out. What is the cost for each song and what is the cost for each game? So we need to set up our variables first by choosing. Maybe we'll let S equal the cost per song and G equal the cost per game. So that's the first step, Keen. You need to copy this down, please. So the first equation then will be for the first order. There were 5 games, so that's 5G, plus there were 4 songs, so that's 4S, and that total is 26. The second order consisted of 3 games, so that's 3G plus 2 songs is 2S equals $15. So there's our 2 equations. We've been doing quite a bit of this, writing equations from information that we're given, so hopefully by now this makes sense to you, where these equations come from. And we want to solve this using the method of elimination. The coefficients in front of the g's are not the same. They're not opposites. They're completely different numbers. Same thing with the coefficients in front of the s's. They're not the same. They're not opposite. However, if we multiply the second equation by 2, that would give us a 4s, which would match up with the 4s in the first equation, and then we could subtract these 2 equations. So that's what we're going to do. I'm going to multiply that second equation by 2, so all the terms get multiplied by 2. The 3G becomes a 6G, the 2S becomes a 4S, and the 15 becomes a 30. I multiplied all three terms in the second equation by 2. The first equation will stay as is. And because the coefficients in front of the s's are exactly the same, we need to subtract these equations. 6g take away 5g gives us 1g, or just g. 4s take away 4s cancels, they're gone. So you're left with 30 take away 26, which is 4. We've got half of our answer. We found g equals 4. The cost of each game is $4. To find out what s is, let's use the second equation, only because the numbers are a little smaller. 3 times g, which we found to be 4, plus 2s must equal 15. 3 times 4 is 12. If we subtract the 12 from both sides, 15 take away 12 is 3. So you'll have the 3 on the right. And dividing both sides by 2, s will equal 3 over 2, which is exactly 1.5. The cost of each song is $1.50. That's what that tells us. To check this, I would go to the scenarios. If we take what we found for the cost of each game and multiply by 5, and the cost of each song and multiply that by 4, we should get a total of $26 for that one. And then we'll check the other scenario once our calculator wakes up. But while I'm waiting for that, let's go on to example 2, and we'll start at least getting it set up. A group of people bought tickets for a University of Alberta basketball playoff game. 2 student tickets and 6 adult tickets cost $102. 8 student tickets and 3 adult tickets cost $114. What was the price of a single adult ticket and the price of a single student ticket? That's what we're trying to find. We want to know the price of each adult ticket and the price of each student ticket. So we might let A equal the price per ticket for adults, and maybe S equal the price per ticket for students. And then we will write our equations. 2 student tickets, so that's 2S, plus 6 adult tickets would be 6A, is a total of $102. 8 student tickets, which would be 8S, plus 3 adult tickets, 3A, equals $114. There's our 2 equations. If we look at the coefficients in front of the s's, they're not the same and they're not opposites. Same thing with the a's, they're not the same and they're not opposites either. I've got 2 choices here. If you multiply that first equation by 4, that'll give you 8 s's there as well, and then you can subtract them. Or you could multiply the bottom equation by 2, which would give you 6 a's there as well, and again, you can subtract them. That's what I'm going to do. I'm going to multiply the second equation by 2. So that'll give us 16s plus 6a equals 228. When I multiply all 3 terms of the second equation by 2, that's what we get. The first equation I will leave as is, because it has a 6a in there as well. And because the coefficients in front of the a's are identical, we will subtract these equations. 16s minus 2s is 14s. The 6a's cancel. And when you subtract 102 from 228, that'll give us 126. So to find out what S is, we'll divide both sides by 14. And that'll give us S by itself. And that'll equal whatever 126 divided by 14 gives you. 9. There's your price for student tickets, $9. We'll take that and plug it into the first equation here in its original form. 2S, which is 9, plus 6A must equal 102. This will allow us to find out what A is. 2 times 9 is 18. If we subtract the 18 from both sides, you'll get 6A equaling 102 minus 18 is 84. And then we will divide both sides by 6 to get A by itself. 84 divided by 6 is 14. So there's the price for the adult tickets, $14. So to check it, we will look at both scenarios and make sure that it works out. The first is that 2 student tickets, we found the student tickets to be $9, so 2 times 9 plus 6 adult tickets, and we found the adult tickets to be $14, equals 102, which is what it's supposed to equal. Then 8 student tickets, so 8 times 9 plus 3 adult tickets, 3 times 14 should equal 114, and it does. So that one checks. And we'll write a statement. Always should write a statement for these adult tickets. Cost $14. And the student tickets cost $9. Okay, now let's go back and check the first one now that we have our calculator. We said that the songs were $1.50 and the games were $4. So the first order consisted of 5 games, so 5 times 4 plus 4 songs, 4 times $1.50 or 1.50 gives us our answer of 26. So that one matches. The second order consisted of 3 games, so 3 times $4 per game, plus 2 songs, 2 times $1.50 per song, should equal $15, and it does. So the first one checks as well. And we'll write our statement here that games cost $4 each, and songs cost $1.50 each. All right. Number 3, during lunch, cafeteria sold a total of 160 muffins and individual yogurts. So that means, what that's meant to mean is that all the muffins and yogurts added together totaled 160. The price of each muffin was $1.50. Each yogurt was $2, and they collected $273.50. Set up and solve a linear system in order to determine the number of muffins and the number of yogurts sold. So that's what we're trying to find. So that's what our variables have to represent. So we might let M equal the number of muffins and Y equal the number of yogurts. Keen, what's our first equation going to be? What's our first equation going to be? Can I ask you another question, Keen? When are you going to pay me your pops that you owe me? Jan, what's one equation? So yeah, that's one of the equations. That's the one that probably is harder, because the other one would just be M plus Y equals 160. There's a total of 160 things that were sold. But yeah, it doesn't matter what order you do them in. If we compare the coefficients of the M's, they're not the same or the opposite. Same thing with the coefficients of the Y's. They're not the same and they're not the opposites either. It doesn't matter which variable we eliminate. You can either multiply the bottom by 1.5 and then you can eliminate the M's by subtraction, or you could multiply the bottom by 2 and eliminate the Y's by subtraction. That's probably the easiest way to do it. Multiply the bottom equation by 2. So that'll give you 2M's plus 2Y's equals 320. We'll keep the first equation the same because it also has a 2Y in it. And then we will subtract the equations. 2M take away 1.5M will leave us with 0.5 M's. When you subtract the 2Y's, they cancel. So on the right side, we need to subtract the 273.50 from the 320, which is 46.50. You with this, Brock? And then we will divide both sides by 0.5 to get M by itself. So the 46.5 divided by 0.5 is 93. There were 93 muffins sold. To find out how many yogurts, let's use that second equation from the very start, that M plus Y equals 160. To get Y by itself, we would subtract the 93 from both sides. Which will give us 67. That means that there were 67 yogurts sold and 93 muffins. So we'll check that. If we add those together, we should get our total of 160, and we do. Finally, if we had each muffin being $1.50, and there are 93 muffins, so 93 times 1.50 plus 67 yogurts times $2 a yogurt should equal $273.50, and it does. So it all checks. It all checks. We know our answers are correct, so we should write our concluding statement stating that. That muffins, actually we should say 93 muffins were sold and 67 yogurts were also sold. probably easier just to say 93 muffins and 67 yogurts were sold, but there's your answer. All right, number 4. A crop farmer has contracted the Peace Carbon Trust, known as the PCT, to convert some of her cropland into woodland. This will create a carbon sink that is used to offset the production of carbon resulting from her farm activities. The farmer has 500 hectares of cropland, and she earns approximately $220 per hectare for her crops. The PCT will pay her $60 for every hectare of cropland that she converts. She would like a minimum of $90,800 for the year. We want to know the number of hectares that she needs to convert to woodland, and then how many hectares of cropland would then be left. So let's let W equal the hectares of woodland and C equal the hectares of cropland. Our first equation, she has a total of 500 hectares of cropland right now. Some of that is going to be converted to woodland. So our first equation would be C plus W equals 500. So C will represent the hectares of cropland she's going to have left, and W will represent the hectares of woodland that's going to be converted. Now, she wants to make a minimum of $90,800 for that year. She earns 222 hectares, $222 per hectare for her cropland. So 220C will be the amount she earns from cropland, plus the PCT is going to pay her $60 for every hectare of woodland. And again, that number should equal 90,800. It could be more than that, but not less. So there's our two equations. Now, yesterday and today so far, we've been using the method of elimination, but don't forget about the method of substitution. I'm going to use substitution for this one. I'm going to take that first equation. I'm going to get C by itself by subtracting W from both sides. Right? We spent 2 days on this last week. The method of substitution, where you take one equation, isolate one variable, and then that gets substituted into the other equation. Where we see the C in the other equation, we're going to substitute that with 500, take away W. So this is the method of substitution, which we learned about last week. It's also an algebraic way that we can solve systems of equations. So when I multiply out the brackets there, I'll have 220 times 500 is 110,000 minus 220 times W is 220W plus 60W equals 90,800. So I'm going to do a couple of things here. I'm going to subtract the 110,000 from both sides. So 90,800 minus that 110,000 gives us negative 19,200. And also on that left side, I can simplify. Negative 220W plus 60W is negative 160W. I think. Just check that. Negative 220 plus 60. Negative 160W, yep. And so then we will divide both sides by negative 160 to get W by itself. So we'll take that negative 19,200 and divide it by negative 160. That gives us W to equal 120. So that's how many hectares she's going to convert into woodland. So to figure out how much cropland she'll have left, let's use the C plus W, which we found to be 120, equals our 500. So C then will equal 380 when you subtract the 120 from both sides. So let's make sure that that works. If you add the 120 and the 380 together, you should get your 500 acres that she has. Yep. And then if you take the 380 and multiply by that's how many hectares of cropland she's going to have left, and you multiply that by $220 per hectare, and then you add the 120 hectares of woodland times $60 per hectare that they're going to pay her, that equals her 90,800. So our numbers work. They satisfy both scenarios. And we will write our statement to say she will keep 380 hectares of cropland and convert 120 hectares into woodland. So for your quiz on Thursday, you're going to have to be able to do both of these methods, algebraic methods. You will be asked to use method of substitution, and you will be asked to use method of elimination as well. So you have to know them both. Example 5. The perimeter of a rectangular garden is 17 meters. Triple the length is 2.46 meters longer than 5 times the width. Determine the dimensions of the garden. So we want the dimensions. We want the length and the width. So let's let L equal the length and W equal the width. Our first equation will be the perimeter, the distance all the way around. A rectangle has 2 lengths and 2 widths. So 2 lengths plus 2 widths is the total perimeter, which we're told is 17 meters. There's our first equation. Then it says triple the length is 2.46 meters longer than 5 times the width. So triple the length would be 3L, and it's 2.46 meters longer than 5 times the width. So a couple different ways you could do this. Here's one way. Triple the length is bigger than 5 times the width. We're told that. We're also told how much bigger it is. So if I take triple the length and subtract 5 the width, the difference will be our 2.46. We're told how much bigger triple the length is compared to 5 times the width. So that's what I set it up as. If I choose to use elimination for this one, the coefficients in front of the L's are not the same or opposite. Same with the coefficients in front of the W's. In this case, I'm just going to choose to eliminate the W's. I'm going to multiply the first equation by 5, which will give me a 10W, and the second equation by 2, which will give me a negative 10W. I can then add the equations together to eliminate W's. So the first equation times 5. 2L times 5 is 10L. 2W times 5 is 10W. And 17 times 5 is 85. The second equation multiplied by 2, 3L times 2 is 6L. Minus 5W times 2 is minus 10W. And 2.46 times 2 would be 4.92. And now, because the coefficients in front of the W's are opposites, we will add these equations. 10L plus 6L is 16L. Again, when you add the W's together, they are opposites, so they will cancel. And when you add the 85 and 492, you'll get 89.92. Divide both sides by 16 to get L. And that gives us L, 5.62, which would be in meters because that's the unit on the perimeter. So to find out what W is, you can use either of the two equations. I'm going to use the first one, 2L, and L is 5.62, plus 2W, must equal 17. When you multiply the 5.62 by 2, you'll get 11.24. Subtract that from both sides. So 17, take away that 11.24. 2W equal 5.76, which then we will divide both sides by 2 to get W by itself. So 5.76 divided by 2 is 2.88. So let's check to make sure that works. The perimeter needs to be 17. So 2.88 times 2 plus 2 times 5.62, which we found for the length, gives us a total of 17. The second thing we need to check is that 3 times the length, so 3 times 5.62 minus 5 times the width, 5 times 2.88 should equal 2.46, and it does. So it checks. So now we will write our statement. The rectangle measures 5.62 meters by 2.88 meters. There's our dimensions. Okay, so the homework. We're not going to do the last one. It's very similar to the one we just did. You're going to do on page 489 to 490, numbers 7 through 11. Remember the one from yesterday, questions 1 and 4 from these same pages is due for marks. The one from yesterday, questions 1 and 4 from the same pages. This one is not due for marks. The one from yesterday is. Remember that you guys have a quiz on this on Thursday, including chapter 8, which was solving systems graphically. So we graph them to solve them, find the point of intersection. That's going to be on your quiz Thursday. You're also going to have a test on Monday on the same stuff. So Thursday you guys will write your quiz. Friday we'll go through it, and you'll have time to work on your review on both days. And those reviews, remember, are always due for marks as well for your test Monday. And then we have only one unit left, chapters 1, 2, and 3, which will go by very quickly. They're pretty short chapters. Okay? Also remember, Friday, June 9th, last day to hand in any missed assignments. After that, they go into zeros, and your marks will go down. Yes, Keen, you can go to the